computer just managed to lock up on me. Okay, at least. Okay, so I'm a couple of minutes late starting. Thank you for all coming and attending this. If you hadn't been reading the screen, I'm doing outside lightning protection. Then Ward Silver's doing inside lightning protection and drifting into its impact on RFI. Then we have Bruce Barrow doing ferrite's use in RFI. And if time permits, I'm also going to do a small session on RFI. We'll see what all happens here. So one of the things I always do is warn you that you should always follow the local electrical codes. If none exist, then follow the USA National Electrical Codes known as the NEC. Make sure that what you're doing is electrically safe. And the ARRL actually recommends that you vacate your shack during lightning storms. And that's a fairly good idea. As for questions, I ask that you hold questions till the end. For one reason, what I found in past presentations is that whatever questions are asked, I'm going to answer in 1 to 2 slides anyway. So hold your questions. And the other thing is, I've pretty much lost my hearing, so I can't hear very well. So that helps keep things going faster by holding questions till the end. Okay, so typically a lightning strike is 3 to 4 pulses per strike, 10 to 170 microseconds total. The first pulse averages about 18 kiloamps, and 98% falling between 3 kiloamps and 140 kiloamps. So they're pretty exciting currents. Subsequent pulses, as they occur, do drop to about half the current. The Dayton area, I realize some of you are not in the Dayton area, we have about 50 thunderstorms a year. So if you have a 75-foot tower, you're likely to take a 1 strike per year, and that's out of the GE Technical Training Manual. For this presentation, any math that I do, I'm going to keep it simple and just use 10 kiloamps for the strike energy and a 10 microsecond rise time. And NASA actually determined that some of the lightning strikes they measured from spacecraft actually showed that the energy goes all the way up through gamma rays. So it's basically DC through the gamma rays. Okay, so how I learned the hard way was, in 1984, I built a house, and the builder was really friendly. Before I built the house, I said, hey, can I put a tower in this neighborhood, and so on. He said, yeah, in fact, I'll even dig the hole and pour the concrete for you, which he did. And so once the hole was dug, we were over there looking at the construction progress, and the one neighbor walked over, and he looked at the hole, and he said, you putting up a tower? I said, yeah. He said, are you a ham radio operator? I said, yeah. About that, I started getting really nervous. and he said, that's great. It wasn't quite the response I was expecting. And he said, yeah, he says, your lot gets hit by lightning almost every year, and the house over there lost its chimney, and the house over there got almost burnt down, and this house had some other issue. He said, you're putting up a lightning rod. We don't have to worry about that anymore. And I thought, okay. And so he was right. For the first 7 years, I kept taking direct strikes to the tower, and I had damage every time. And about that point in time, I found out that Polyphaser published a book on lightning protection. So I purchased that book, and I implemented everything they said, and I had no more damage the rest of the time we lived there. So the that's where all this information came from. And so I always ask, well, what's the damage? Is it voltage or current? And the answer is both. And the current being the worst of the two because it can burn things up and destroy wires and do all kinds of nasty stuff. And the current also actually creates voltage because you have current flowing through a resistance. It creates a parasitic voltage. And I should mention this session is apparently being live streamed. It'll be available on YouTube later on, I guess. And so anyway, so if you look at current through a voltage, if you have a 10 kiloamp lightning surge, a 1 ohm resistance, you'll have 10 kilovolts across it. So you need to keep your resistances in the lightning's path to a very low amount. If you happen to have an inductor, then the 10,000 amps at 10 microseconds will develop 150,000 volts across that inductance. So one of the things I like to explain is the thing that really damages a circuit is voltage difference. Like if you look at the simple little transistor, if you put too much voltage from collector to emitter, it's going to pop. So the whole tent to lightning protection is keeping the voltage differences to a bare minimum and within the ratings of the parts. And this is, if you look at old school, this is how a typical house was grounded, especially if it's old construction. I mean, if your house was built before like 1980, this is the way it was built. To add to that, typically what happens is, a house is built, you bring the electric in, you bring the phone in, they're brought in at different locations typically, then you added cable TV and external antennas, and they come in at some other location on the house. So you end up with something that looks like this. And that's the worst thing you can do. And by National Electrical Code, this is what should have been done. So I'm willing to bet that 90% of the houses today are configured the way that previous screen was. There's very few actually configured the way this shows. So this is the way you want your house to be grounded. You want everything bonded together. You really would prefer to have them come in at one location. A little bit more on that in a few minutes. And like I say, the single entry point with bonding is probably one of the most important things you can do to stop damage. And this is an example. This is out of Ward Silver's book, and out of the ARRL. And but anyway, this is the single point grounding. This is what in a case like this, if you follow the lightning path through the system, there's no real reason for the lightning to go all the way up to your radio and come back out. It's just going to hit that panel and go right down to ground. So yeah, the radio may float up to some high voltage, but the whole radio is at the same potential, so there's no damage. And this is another example of how you can do that. And resistance can be both a friend and an enemy. From reducing current, higher resistance is good, but from getting lightning to the ground, you want lower resistance. And so it sort of boils down to Ohm's law, except where you have to take inductance into consideration as well. And for example, a half-inch coax, about 100 feet long, is 51 microhenries. Tower is approximately 5 microhenries per 10 foot, and tower joints are 0.001 ohms typically. This is, by the way, all the links in this presentation, if you send me an email, I'll send you a copy of the presentation. That way you can just click on the links. And my email address, just use my call sign at arrl.net. And these are typical soil resistances you will see across the country. And you can see there's quite a range for soil resistance. And once again, higher resistance is bad from controlling the lightning. The National Electrical Code wants your resistance to ground to be less than 25 ohms, and Motorola likes it to be below 10 ohms. Typical telecom switch is under 2 ohms, and Verizon likes to see the ground resistance being less than 5 ohms. And to calculate ground resistance, this is out of the military handbook. And so if your soil resistance is 5,000 ohms, then your resistance to earth is 20.6 ohms. And if it's 2,500 ohms, then your resistance to earth is 10.34. But if you're pushing 10,000 amps through that resistance, that's a lot of voltage. So if your soil resistance is 100 ohms, then it's the ground resistance is 0.41. And if you have one ground rod at 0.41 ohms with a 10 kiloamp current surge, the bottom of the tower is at 4,135 volts. Now, if you have 3 ground rods, one on each leg, now you're down to 0.14 ohms, and you're down to 1,300 volts. And keep in mind that's at the tower leg, and the top of the ground rod will be at a higher voltage. So these are some things you can do to improve grounding. You've got to have at least one ground rod on every leg. That's, as far as I'm concerned, that's bare minimum. It's much better if you do like this one on the right, where the wire goes out some distance and you put another ground rod in, you go out some more distance and drop another ground rod. And typically, if a ground rod is 8 foot, the next ground rod should be out 16 feet. If you use a 10-foot ground rod, the next one's out 20 feet. So the length of the ground rod affects that. The one on the left is probably typical of what you might see for a communications tower for a cell phone, something like that. It's for ham radio, so I've probably never seen anybody do this, but they've got a loop going around the house. In my case, my current loop goes about 2/3 of the house. There's no easy way for me to get around the front to complete the loop. These are, I don't know how well you can see this. In this case, the people tried to be, on the pictures on the left, the people tried to be really neat, and they got lots of 90-degree angles in there. Well, all of those are inductors, and that's bad news from a lightning strike. The tower on the left, they have one ground rod on it. And let's see, we got, here's some calculations. Here's the calculations. With the way that tower was done on the right, it's about 900,000 volts to the ground. This is another example of tower grounding, and I would consider this basically to be the bare minimum. And then the question comes up, what gauge wire should I use? Well, the NEC recommends 10 gauge and 14 gauge. And I looked at that and I said, you got to be kidding. Why would you use such light gauge wire? But there's a reason for that. Polyphaser recommends the use of 10 gauge. Ward Silver recommends 6 gauge or 2 gauge. Motorola recommends 6 gauge. Mike Holt says 6 gauge. My local power company uses 6 gauge. And I currently use 4 gauge. And I've been using stranded, but I bounce back and forth between solid and stranded. Stranded tends to have more surface area, so it's a little bit better resistance. But then you got corrosion and other things getting in the way. And you need to consider skin effect and inductance. So like they sell the strip copper, that's by far the best thing to use because you got tons of surface area. Al Torres used to put content into this presentation, actually gave the presentation himself a few times. He put together what he likes to do is he likes to take old Romex and pull the 3 wires out of it, twist the 3 wires together, and use that for ground wires. That's not a bad idea if you need to use some, if you got some old AC wires hanging around. Al generated this chart, and if you look at 14 gauge there on the left, it can handle 187 kiloamp for 10 microseconds without the wire melting. And so that's why the NEC uses the 14 gauges, because it can handle that. The catch being is if you had multiple strikes fairly quick, you'd be in trouble. But that's extremely rare to happen. For protection, if I can get away with it, I use quarter wave shorting stubs. You can make them yourself, or there's companies that sell them. So like the 450 or 440 repeater that I use a quarter wave shorting stub on that repeater. Quarter wave shorting stubs can take a 100 kiloamp lightning strike and just laugh at it. It can handle 10 kiloamp strikes all day long and not care. So you don't have to worry about replacing arc devices inside the arresters. They just work. But if you got an antenna that's multi-band like HF or a dual band VHF, UHF, you can't use the shorty stubs. You've got to use the standard lightning protector. I use AC line protectors. I only use Triplite or SGL Weber. Triplite and SGL are both owned by Eaton nowadays. And I only use electrical strips that have been certified by an agency like UL, NEMCO, CSA, ETL, and some of the others. It helps ensure that you got a safe product. Now, the other thing I'll mention about Triplite is a lot of people look at the price of those things and say it's not worth it. The catch is they have RFI suppression in them. So they actually have ferrites in there. And so not only do they have a lightning surge protection, but they also have EMC filters to knock the RF down. They're rated 40 to 80 dB of isolation. I think the 40 dB is down in the kilohertz range and the 80's up in the 6 meter band. And it's sort of a line between the two. I've been trying to get them to confirm that for me, but so far I haven't been successful. But anyway, not only does it provide lightning protection, but it also helps your computers and other such things from driving RF signals back through your power wires, which then get into your HF antennas. You should also have an AC line protector, surge protector at the service panel. Should be installed by a licensed electrician. All guide wires need to be grounded. And these are some examples of bonding. The picture on the left, once again, it's out of the ARL book, but the picture on the left is the way that my system, my current house, and the ground near the towers, or poles. All the poles in my area are properly grounded, and I've never had an issue with that. But I also know Mike over here, he's got copper thieves that run a path along his poles that seal the copper wire. So I don't know how cooperative they've been on fixing that. So, you want to come up here? And that way it goes live stream.
Yeah, I live by a bike path that goes down on the house. Used to be an old railroad track. And there's power lines that go down the side of that right-of-way and on wood poles. And they all originally had pole grounds on them that basically goes to the bottom of the pole, and it's coiled at the very bottom of the pole. Copper thieves came through, and as high as they could reach, they cut those off, every one of them down the line. As far as I know, they have never been replaced.
Okay, I think it's all another. It's the old. I'm sorry.
I asked if you used a Lightning app on a phone, which.
Oh no, I don't use that.
I use it, and it shows. I mean, you get a message when you get lightning within 30 miles, and it shows you right down to the pole in front of my house that got struck by lightning, which I found useful. I just
okay, I have to check that out.
It's called Lightning Pro.
I saw somebody.
Do you disconnect your equipment?
Second?
Do you disconnect your equipment
Never.
Never have?
Never.
Okay.
The repeater I have is on 24/7. It gets hit basically every electrical storm, and I don't have any damage. We did have, when I was using some low-cost antennas, it blew the antenna apart. But since I put a Super Station Master on the repeater, I've had no more damage. I had one over here. Can you hear him? you're going to have to come. So, my hearing is shot. It's a bad hobby to have bad hearing. But
I have a crank up tip over tower, has 3 guy wires on it, but they were at a resonating length, so I put an egg insulator in there. Now that, how do I ground the guy wires with the
put a spark cap across it.
Gotcha. All right, thank you.
That'll address that. Because if you got a resonant tower, like the your AM towers are like 900 feet tall. They can't be grounded because the tower is actually the antenna. So they can put spark gaps across it. See anything? Okay. I saw you. Can you walk up here? And,
Loudmouth. I think everyone can hear me, and I just have something short. I bought Ward's book and read it, and it's great. So I recommend everybody buy the book. You know, I'm not going to do everything he tells you to do, because if you do what he tells you, then it's perfect, and most of us are less than perfect like me, so I'm not going to do all of the things he said, but it's a great book, and now I still keep it in the shack for reference. So it's not just to fix a problem, put the book away.
Yeah.
Use it as a reference.
I saw some more questions.
So I am in the process of installing a tower, and I live in an area that has really poor soil conductivity, and I just wondered if you had any recommendations other than just putting a whole bunch of rods in the ground. Is there anything else that we can do to improve the conductivity where we are?
There's chemicals you can add, but I don't know how safe they are to use in a regular yard. But I would just put in more ground rods and spread them out. And
Radials.
yeah.
So I'm also installing a tower, and I have Ward's book, and I'm spending an enormous amount of money to do what he recommends. All right, but my question is, my Radio Shack right now is on the 2nd floor of my house. The single point panel is at the entrance of the house at ground level. Do you have any special suggestions or recommendations practically to deal with a situation like mine where the radios are up on the upper floor and the panels on the bottom?
If everything comes in at the single point, you should be okay. I think that's. I don't know if you have any. Oh, he's going to talk about that. We got about 1 more minute. Ward, you may want to load your. And for some reason I can't get the keyboards non-responsive, so I'm not sure how easy it's going to be to do that.
I'm putting in a new tower and everything, and I was just ripped all the water tubing out of the house, copper.
Yep.
And would that work as my ground thing to bury that about 3 feet down?
Yeah, copper.
And drive rods
Yep.
too, but everything below ground level, bring it in.
Yep. That should be pretty good. Any other questions? Okay, we'll see if how easy he can get the computer to cooperate and get his PowerPoint on there. I couldn't get the mouse to do or anything.
Oh, okay.
Let me call.
Well, I don't. Well. Do we have a wireless mouse or something?
Yeah, keyboard's working, but anyway, I'll address your issue about the 2nd floor station. Okay, the important thing is bonding. Okay, everything in that station needs to be bonded together so that it all goes up and down together at the same voltage. Okay, you're like an airplane in that case. The distance between a 2nd floor station, I have one, and a ground is so long that trying to run any kind of a conductor to make a ground connection, it's too much inductance. It's not, you could put a 3-foot wide strap and it'd still have inductance. So what you do is you bond everything together. You've done the right thing. You spent a lot of money. and your single point down here at the ground. That's exactly what you want to do. You want to run all your cables to something. That's where your single point is. And then you run your protected stuff up the side of the house. Keep the protected cables away from the unprotected cables so the lightning doesn't jump around your protection and your panel. And then up at the top, you bond it all together. And then it's also connected to your AC safety ground up there. If you run any antennas from your roof, you run them away from your protected stuff down to the single point and back up. So you have to spend more money on coax, but that's the deal. And then I just tell people when there's a big storm or something, just don't hang around your equipment. Okay, there's really not a lot you can do when you're sitting up there at an exposed second floor. But the key is bonding. So if there are any transients that are coming in, everything goes up and down together and you don't get destructive voltage differences between parts of the equipment.
There we go. I'm too old for this. All right. What's that?
What is your recommendation then for connecting that second floor, given the inductance problem? Right. So how do you then connect everything you've bonded at the top to that single point ground at the bottom? How do you make that connection?
Okay, you make the connection through the shields of your feed line. That's going to be a large diameter conductor, the outside of the coax. And for the lowest frequency components of the lightning, which are down near DC up to 100 kilohertz, you can provide some ground protection for that. But it's the high frequency components that cause the very sharp transients, and that's very difficult to ground out with a long connection. So there's no point in putting a big copper thing outside. You've already got half a dozen large RG-213 or something like that. Those are pretty good connections. Just make sure your connections are tight and they're waterproof, and that's about as good as you can do. You know.
Flat copper strap reduce the impedance?
What about flat copper strap? The standard is a 2-inch wide copper strap. Once you get beyond that, I found out that what happens is the eddy currents drive the current to the edge of the strap. So anything beyond 2 inches will work at lower and lower and lower frequencies. But where we live as hams, 2-inch, 1.5-inch, 2-inch copper strap, 20 gauge is about as good as you can do. No, it doesn't. If you run this stuff down from the upper floor to the bottom, it's too long. There's a number 12 wire, 1 foot long, has 330 nanohenries of inductance. And if you hit that with a kiloamp per second, per microsecond pulse, you will have 700 volts across that 1 foot piece of wire. And so the problem is, as the conductor gets longer and longer, the inductance gets higher and higher, and the reactance goes up. And at high frequencies, which is what we really care about at RF and the higher frequency components of lightning, it looks like an open circuit. So you're stuck. You're like an airplane on the second floor. So all you can do is your safety ground and your low frequency ground, and you're doing that through the shields of your feed line, which is acceptable by the neck. They allow you to do grounding. So you got it up. All right. What did he do? What was? All right. When I was young, I'd just hop right up here, but yeah.
Use that page to go forward, that one to go back.
Okay. All right.
As soon as that,
Ooh, there we go. All right.
as soon as he got to the door, it started working.
Of course.
All right, thanks. Great. I also had some other comment. When you put your protectors on the single point panel, one of the reasons why you want your protectors all on the same panel is so everything fires at the same time. And this was something I learned from Ron Block, who's a polyphaser guy. Ron is also coming out with a new book. It'll be a free PDF, as far as I know, on lightning protection. So this will update his articles in QST from 2002 and incorporates a lot of stuff that goes beyond what's in the ARL book. Thankfully, it doesn't conflict with what's in the ARL book, but Ron was one of my reviewers. He's really good. Okay, so background references. What I'm going to talk about is bonding, okay? Jim has talked about lightning protection systems and how you protect against these really big surges. The next step in the system is to bond within that system. So what Jim talks about is you're outside dealing with Mr. Lightning, really high energy stuff. Now we're going to move into the RF world, which is up at the high end of lightning, plus up through HF and into low VHF. So we're going to bond within that system. So I talk about that in the book. It does cover the basics of AC wiring, safety, lightning protection, and we get into what I call RF management. I really try to avoid the term RF ground because there really ain't no such thing over the wide range of frequencies that we use. The experts that reviewed the book were Ron Block, NR2B, one of the polyphaser guys, Jim Brown, K9YC, who has done a lot of work with ferrite, and he's a pro audio engineer, so he knows about bonding, the ARL lab, Dale Svetnoff, WA9ENA, who's a lightning consultant. And it's not a step-by-step, here you do this, and then you do this, and here you do this. There's too many different circumstances, so it's kind of a toolbox and a description of the techniques, and then you go home and you go, okay, what have I got? What was he talking about? What can I do? And it's, I don't expect you to do everything that's in the book. I expect you to do what you can within your budget and your resources. Okay, so what is bonding anyway? It sounds expensive. If you go look at it in the dictionaries, all it is a connection between 2 points to keep them at the same voltage. The important thing is in your station, you want everything to go up and down together. It's like a floating dock. It allows a wave to come through and all the boats go up and down with the dock. So I will make this motion several times in the talk. Everything goes up and down together, and that keeps destructive voltage differences from appearing between different parts of your station. It's the same thing in a home entertainment system or your computer system. You want everything to go up and down together, and that's why you bond. It also prevents shock hazards from voltage differences if you have a fault, like a short circuit or something like that in your equipment. Everything's tied together so you don't wind up with a hot piece of equipment. The voltage differences are what causes the damage. These short, they can be very short, but lightning and electricity are really, really fast. So if you get a multi-kilovolt spike over here and it hasn't gotten over here yet, suddenly you've got multi-thousand volts between different points in your system. And this is when you hear stories about sitting there minding your own business and there's a thunderstorm and whammo, there's a lightning flash and suddenly there's this big green flash between pieces of equipment and nothing works anymore. That's what's happening, is a sudden sharp voltage difference. So by bonding and tying everything together, you can minimize those voltage differences. RF pickup is also caused by voltage differences. What causes RFI is current, common mode current or some other kind of induced current that flows between 2 points and gets to where it should not be. Gets into an input on your microphone, your audio, whatever. So what causes current? It's a voltage difference. So if you minimize the voltage differences, you also minimize the current flow. So that's another thing that bonding does for you. And it sounds really hard. It sounds like, oh my God, I got to go buy all this stuff. It's going to be really difficult. I'm going to have to very carefully do this and that. I'm going to take my station all apart. It's not really very hard. And it sounds expensive. It's not, you don't have to weld things together and all this kind of stuff. You know, all that Romex that you won't throw away if you're like me, you know, you've got a 3-foot piece. I'm going to use this someday. Well, this is what you are living for, ladies and gentlemen. That box in your garage full of cable, this is it. Okay, the number 14, number 12 that's in Romex, that is perfect for bonding at RF. It's really good. The surface area of a number 12 is almost equivalent to that 1.5 inch, 2 inch copper strap. The military and the commercials, they like the 20 gauge strap because it works a little better. But number 12, number 14, heavy, solid, direct connections are almost just as good, and they cost a lot less. Unless you have a brother-in-law in the roofing business who has a whole lot of scrap flashing, in which case you're ahead of the game. Okay, so when you're going to do bonding, you still have to use the right connecting materials and the clamps and the hardware and all this kind of stuff. But it's not really very expensive. Most of it, if not all to your station, he's like, this guy's too much trouble. I'm just going to go into the ground. So lots of little protective steps. And yeah, I don't know why they call it wireless. I've never seen so many wires in all my life. I urge you to go and look at Ron Block's QST articles from 2002. They're publicly available whether you're an ARRL member or not. They're in the technical pages, and look for safety. And you can just search for Ron Block in the search window. If the website's back up yet, I don't know. Ron talks about creating protected zones. So that could be a home entertainment system, it could be your radio station, it could be your computer system. Everything that goes in and out of that protected zone has to be protected, and it also should be what you're trying to create is these little electrical islands where everything goes up and down together, and you've got some protection against transients and destructive energy coming in. Really a good read, three-page series. Okay, the next thing to remember is that absolutely everything in the station is an antenna. You're so close to your antenna system. For example, you've got a 40-meter dipole in the backyard. What's the wavelength at 40 meters? Trick question, it's 40 meters, okay? So that's 120-something feet. So if you're within a couple hundred feet, you're in the near field of that antenna. And everything that conducts energy, conducts electricity in the house, the AC wiring, your ground connections, your jumpers, the microphone, everything is an antenna. So you can't just find a 0 volt point and clip to it and you're like, solve all your problems. Doesn't work that way. So we forget about an all-band RF ground. The frequency range for hams is way too broad. It goes from medium wave, 1.8 megahertz and lower, all the way up to literally light. So it's a service. We're kind of unique in that regard. We have the widest possible frequency range and the lowest possible budget. Okay, so you just have to use what you've got. So forget about trying to create an RF ground, magic 0 volt point. Concentrate on bonding. Create some kind of a bonding system in your station that works for you, ties everything together with electrically short connections. If you can avoid it, I know how it is. You know, you've got your radio, it's on the desk, it's up against the wall, and you want to make some kind of ground connection. So you've got to make it long enough so that when the radio is pulled out, you can make the connection, right? And then you shove it in there and the thing goes like this and makes a big inductor. If at all possible, make it flexible so you can reach around there and just kind of connect them together. Keep everything at the same voltage. If you have an amplifier, you have high RF field strength, it's going to find all the weak points, and you'll also meet the neighbors. That's really handy. So that requires a little extra attention to bonding when you put in an amplifier. One technique that's very common and we've seen pictures of this in the handbook for decades, literally, is the piece of pipe behind all the equipment, and you bond to that, and that acts as a bonding bus. Something that works even better is a plane underneath. If you have a metal desk, metal shelf, something like that, or just get a piece of flashing. Good old aluminum flashing you get at the hardware store or from your brother-in-law in the roofing business, and you lay that under the equipment. You can get the big fancy panels if you want. They work, but what works best is just a big, long strip of metal underneath everything. And so it's got capacitance from your equipment to this, and then you connect the grounding to that panel. You can put a little bounding bus on the top of it if you want. Some people will use a 1/2-inch copper pipe. You can put that right on this strip of metal. I've started to use the little grounding bar accessories you can buy in the electrical department of the hardware store, and they'll sell you a 9 or a 15 or 27 position thing that's designed to go in a circuit breaker box. Works great. Just drill a couple of holes into the unfortunate table that you're using for your station. Use lock washers with external or internal tooth lock washers so they bite into the metal, and then you've got these great little grounding points for everything in your station. You can put 2 or 3 along the reference panel. So that kills all the hot spots, and you don't get as much RFI from common mode current thrashing around. And any RFI you got left over, Bruce is going to tell you how to kill it. And it also reduces sensitivity to physical configuration. We've all operated at a station. The guy says, oh, if you want to operate 15 meters, you got to move over here and you got to stand on one leg, and you can only touch the microphone with one finger, you know. So what this does is it just flattens all that out. The best time to do it is when you're building a station, because everything's already off the desk. Put down that piece of metal and work from there. Okay, when you do get your bonding stuff together, what you want to do is minimize the loop area. Loop is what picks up the energy from RF or lightning strikes and induces a voltage in, it's like a one-turn secondary in a transformer, and that causes the current flow. So if you minimize the area, you minimize the pickup. Use short or coil cables. I know you go try to buy a USB cable. It seems like the shortest thing you can buy is 20 feet. But look for the short ones and use those. And if you can't buy a really short one, then coil it up. And when you coil it up, do it in a figure 8. And the figure 8 tends to cancel the inductance, so it's not like you're winding a multi-turn secondary on a transformer. Use shielded cables for everything. Absolutely everything except maybe power. Then you've got that shield, you've got your metal enclosures, you've got a path for the RF to go someplace other than into your equipment, and short straps and wires everywhere. Here's an example of a reference plane. This is one of the operating positions at my station. You can see the shiny thing, that's aluminum flashing attached to an unfortunate Costco folding table. And in the back is my bonding bus that I've clamped to it. I've since replaced the bonding bus with those little multi-point ground bars that you can buy in the electrical section near the circuit breakers. And that works just as well. And all of my cables lay on that reference plane. So the reference plane shorts out whatever RF is coming in, minimizes the voltage so it doesn't get picked up on the cables. Seems to work pretty well. There's a couple of bands. I have a couple of hot spots. I bought some of Bruce's ferrite, killed it. I'm pretty cold at RF at this point. Okay, here's your additional resources. The National Fire Protection Association has a lot of good stuff. They're the people that write the electrical code. And the fact that it's written by a fire protection association tells you a lot about why the electrical code was needed in the first place. The International Association of Electrical Inspectors, this tells you what they are looking for. What's even better is to find an electrical inspector, and when you do some work, major work on your station, have them come over and take a look. You know, if it's your brother-in-law and you give them a six-pack and they look over your shoulder and they say, that's a good job, or you really don't want to do that, that is the time to find out. Or hire somebody that knows what they're doing. You know, I know we're all ham radio operators, and by definition, we know everything about everything electrical. But once it gets complicated, or you start doing a separate out panel, a separate circuit breaker panel, especially for outbuildings, you can create significant electrical hazards. So if you don't know what you're doing, please, please, please find somebody that does, so you don't hurt yourself or burn down your house. Mike Holt, Jim mentioned those. Polyphaser, there's a lot of resources on the Polyphaser webpage, including white papers that are specifically for hams, because both of the Polyphaser brothers were hams, and they understood that we needed this kind of information. Here's the standards. So if you really have trouble sleeping, okay, and you need a little extra help, standards and guidelines. This is the famous Motorola R56 standard. It's available online. Just search for it. You don't have Motorola's budget, but this is designed for large communication sites. And you can look at the pictures and look at what they're doing, and you go, well, you know, I can't do that exactly, but I can follow these general guidelines, and that will get you a lot of the way there. There's an FAA document on how to build these communication stations. You paid for it. It's free. It's out there. IEEE standard 1100 is for electrical safety. It's expensive, but it's available at your library. You probably don't really need it unless you're an engineer that wants to do a deep dive on this stuff. And then Mill Handbook 419A is what happens when the military builds a big HF station. Now, and they have a significantly higher budget than we do, but you can, again, you can kind of follow the guidelines. Here's some good books. Ron Block wrote The Grounds, and that's available from Polyphaser. There's probably a bunch of copies out there. This guy ran lightning protection and grounding solutions, and then the ARL Technical Information Service, which is really one of the unsung gems in the ARL technical pantheon. They have an electrical safety page. There's one on grounding. There's one on lightning protection. All this stuff is out there. It's free. It's available to everybody, whether you're a member or not. I hope you're a member because that supports this type of information. But the information is out there for you. So thanks. I'll take a few questions, and we'll let Bruce go. And I'm going to come down there so I can hear you. Why don't you say your question into the microphone?
Ward, I went to a presentation on Friday called Ground is a Myth by Kristen McIntyre. And not to go into the many differences between what you said, which I believe, and what she said, the one thing that was the most concerning was she said that you should not connect the common ground point between all of your radio components to the outside ground.
Kristen and I are saying the same thing with different words, and what she's talking about is this single, that we hear about single point ground. Okay, the original use of that was from electricians trying to prevent error currents and circulating neutral currents and other things. Okay, so Ham's got this notion that, well, I'm going to connect all my stuff, no matter where it is, to one single point. Problem with that is you get these really long connections, and they're useless at RF, and it can actually cause problems. So that's why you bond everything together, and then you connect it with a single connection. Am I going to have to talk to Kristen? Okay, I'll talk.
Because God knows, I heard somebody else say it. I certainly could have misunderstood what she said, but I very clearly remember her saying that you need to bond everything in the shack together, but you don't need to connect it to the outside single point ground.
I'll have to talk to Kristen. Okay. Yeah, because you've got to bond that stuff all the way through your system. Otherwise, you create these points that suddenly diverge dramatically in voltage. See, Kristen doesn't live in a lightning area. She lives in San Francisco. If she lived in Florida, she would never, ever say that. Okay. Yeah, come on up and say the question so that everybody can hear it. You go
Most of your discussion was on the internal grounding system and bonding. Do you recommend, or you didn't mention anything about exothermic welding for external bonding?
Oh, my favorite, exothermic welding. Okay, how many people have used a CAD weld or a one-shot? Isn't it fun? Oh, yeah. You know, I remember looking at the video. It's on KF7P Metalwork website about how to do this. And he lights it off, and suddenly, woof, you know, and I thought, oh, they must have speeded that up, you know. But no, you know, you put this little mold on your ground rod, you put the wires into it, you pour in the stuff, and then you put in the lighting powder, and you hope the wind doesn't blow it away. Here's a tip. I'll save you 10 or 15 bucks that you'll learn the hard way. The wind will blow that powder right out of there just about the time you're ready to light it off. So, and then you can use a sparkler or a little sparker, and it goes from 0 to 2,000 volts like that. Okay, what you wind up with is a big ball of molten metal inside this little ceramic mold, and you're using number 6. You've got a 1/2-inch ground rod. It's all one big welded thing. You'll never have to worry about digging it up to inspect it. It'll never loosen up. It's great stuff, but you got to use exactly the right mold, or the hot metal will leak out. So if you've got 5/8-inch ground rods, you got to use a 5/8-inch mold. If you're using number 6, you got to use the number 6 mold. They've got a million different versions of this stuff, but any electrical contractor will have what you need. DX Engineering sells them, KF7P, all that kind of stuff. Fun stuff, and you can bury it and you'll never have to worry about it.
You were talking about using a plate on your shack. As far as cheap, can you use window screen? Does the mesh make any difference?
It doesn't have to be solid. If you've got brass screen, if you've got you go out and you find metal shelving that's got a mesh or something, that works great. The point is to get the holes much, much smaller than a 20th of a wavelength, and then it begins at the highest frequency, okay, and then it acts like a solid thing. N0 and I has a big station in Iowa, and he went out and bought surplus restaurant racks, which are those, chrome-plated things. It has a lot of ventilation for the equipment, and he can bond it all together, and so he's got a big solid metal bonding thing. Who's next?
I'd like to return briefly to this topic of shacks on the second floor, and I'd like to revisit a point you made about reliance upon, rather than a big strap, an inductor, reliance on the actual braid and the multiple coax lines you're running up there, right? With respect to that, this is a two-part question. With respect to that, does it matter at all what type of connectors you're using on the coax? I mean that both with respect to UHF connectors versus N connectors, and I also mean that with respect to whether you're using a clamp connector or using soldered connector. That's the first question. And the second question is, in my case, we're locating the single point panel right now on the ground. Shack's on the second floor. There's a big piece of gutter that runs right down the corner of the house within a foot of the panel box where the single point panel is going to be. Now that gutter is not connected to anything, right? Is that a problem? So those two questions.
I'll try to remember both of them. Okay, the first one, does it matter what kind of, if you're going to use the feed lines as a grounding connector, does it matter what type you use? PL259s and N connectors are just fine, okay? You do have to ensure that they are properly crimped or soldered, but the main conductor is the outside of the shield, and that would depend on the size of the coax. But anything that we are going to use outside RG8X, RG58, 59, or 213, 8, etc., will be perfectly sufficient. The important thing there is waterproofing, weatherproofing. Do that right so that water can't get in there. Water is the enemy of RF. Second question was, If I recall correctly, you've got a big gutter, outside metal gutter, something like that. I wouldn't try to use it unless it's the really expensive copper pipe type stuff, in which case you've got more money. You wouldn't be here asking me these questions. Okay, so the idea, I would not use the aluminum standard gutter as anything. Here, come on back up.
The intent of my question was whether or not, in a lightning strike situation, the floating inductance of that gutter in close physical proximity to the single point panel box is a problem.
Yeah, mutual. Does it couple in? Not really. You've got two big, essentially parallel.
I think we all have a switch mode power supply. There'll be a ferrite core in there. Connectors, we make flat plates that go inside connectors to absorb EMI. Medical equipment, MRI machines, we sell to MRI manufacturers. If you've bought a washing machine in the last 3 to 5 years, they've gone from almost a completely mechanical assembly to one that's almost all electrical. It's got a microprocessor in there. Ferrite is used in there. And finally, energy, photovoltaic, rooftop photovoltaics use our product as well, although a lot of you guys are having problems, I'm sure, with rooftop EMI. So again, only about 3% of our product ends up in the hobbyist market. I like to show this slide because we get the question all the time, something that goes like this. I'm on 40 meters. I have about a 40 over S9 noise problem. I clamped on a piece of ferrite and it didn't do any good. So I'd like to show this formula. The formula looks complicated, but it really isn't. It basically says that the amount of attenuation you can expect is basically the impedance of the load, the impedance of the source, and the impedance of the ferrite over those items. If you do the math, because we have typically a 50 ohm impedance for your transceiver, a lot of us are using a half wave dipole that wants to see 50 ohms. Once we work out the math, a typical ferrite core will provide about 5 to 8 dB of suppression. If you have a 40 over S9 noise problem, one piece of ferrite's not going to do it. In fact, 50 pieces of ferrite probably aren't going to do it. There's a limited amount of suppression that a ferrite can supply. It's not infinite. So we get that question 2 to 3 times a week. I clamped on a piece of ferrite. It didn't do a lot of good. So knowing what to expect from the ferrite that you get is important. About 5 to 8 dB is about all you're going to get out of one piece of ferrite. Let's talk a little bit about common mode EMI versus differential mode EMI. Common mode EMI is where the noise travels in the same direction down both the supply and the return. Differential mode goes down, and this is probably the most common form. EMI goes down one source and it goes back in the different direction back to the source. Common mode is difficult sometimes to diagnose and to fix because that noise is going to come back to the source either through a chassis, a ground. It'll find a way to get back there. I found out is when I had my novice ticket back in the 1970s and upgraded to general. The reason I knew I had common mode is I had a D104 microphone that I was very proud of. And once I put my lips close to that microphone and touched it, I got a good RF burn. A good example of common mode. It was basically that RF is finding a way to get back into the shack. So we fight it in different ways. Common mode, basically the definition is you use a single core and both the supply and the return go through the same aperture core. Typical, for us was we'll take a ferrite and clamp it around the coax. Both the center conductor and the return shield go through the same piece of ferrite. Differential mode's different. you're basically going to just put it on maybe one leg of a MOSFET that's carrying a signal and probably also a DC current. Common mode has the advantage of letting the target signal pass, and it will absorb the higher frequency EMI because the magnetic fields inside that core are equal and opposite and will actually cancel each other inside the core. So what does that mean? That means the core is not going to heat up. A lot of times if you're using it in a differential mode application where you've got just, say put it on one leg of a MOSFET, that core will actually heat up, and if there's a large enough DC bias passing through that line, the core will actually derate severely in impedance. And here's a good example of this. If you take a look at the impedance graph there, and different amperages are listed, 0 amps, 0.2 amps, 0.5 amps. This is actually, I believe, an FR61 core. Look how the impedance derates. If the core sees enough bias current, it will severely derate down to almost 0. In fact, it will get to the point where it will provide no impedance at all. So knowing these secondary characteristics of a ferrite is important when you pick one out. So how do you select the correct current? Basically, you have to estimate where you've got a differential mode problem or a common mode problem. Most problems hams face are common mode. Most manufacturers face a differential mode problem. How much attenuation is required? Again, using that example I was using before, if you've got a 40 dB over S9 problem, ferrite's not going to fix the problem. Do you have DC currents running through? Different ferrites react differently to DC currents. And basically form factor. Do I need a clamp on? Do I need a PC bead? We make all of those products. This is a good slide. I just want to cover this again because we talked a little bit about it earlier. We talk about complex permeability of ferrite. Again, permeability is if I take a piece of ferrite, wrap a wire around it, pass a current through it, I get a magnetic field. Higher permeability ferrites will generate a stronger magnetic field. The mu prime, the little U there with the prime next to it, is the reactive portion of the ferrite. That's where ferrite makes a good transformer core, perhaps a good inductor. Notice how as the frequency increases, and this is our FR61 material, at a certain point around 10 megahertz, that reactive portion drops off dramatically and the resistive portion starts. So if I buy an FR61 ferrite and I want to use it as a transformer core, it's probably going to work out to maybe 10 or 15 megahertz. If I buy it for suppressive purposes, it's going to work above that frequency range. So this chart just demonstrates that depending on the mix, almost all ferrites can be used in a number of different applications, but knowing the frequency of where you want to use it is important. These charts are available on the ferrite website and on our competitor's website. Another important tool to know is that if I pass the ferrite core, or pass a current carrying conductor through a ferrite core, and I just wrap it around the ferrite, or there's one pass through, I get a certain amount of impedance. If I take it twice, if I wrap it around twice around that ferrite core, I square the impedance. So if I have 10 ohms with one pass through the aperture, I wrap it around twice, I have 100 ohms. It'll square again. So if you need to get more impedance out of a ferrite core, more passes will dramatically increase the impedance to the point where you'll get thousands and thousands of ohms. Just want to cover one last thing on ferrite manufacturing. I talked a little bit about it. A lot of times we have hams that think it's like a liquid that pours into a mold. It's not. Basically, every piece of ferrite that we make is done under is made by forming. In other words, we have a press. Those pieces of ferrite that you see on that conveyor there, that's going into our 600-ton press. Or actually, it's coming out of the 600-ton press. It's pressed to get that like that. Each piece of ferrite has its own unique die. So we have a catalog that has several thousand parts. We have several thousand dies that we keep in stock that are mounted in that press. That punch press comes down, punches out that piece of ferrite. Once it comes out, it's basically in what we call the green state. I can take that piece of ferrite and crush it in my hand. The next step that really forms the magnetics of the ferrite is called sintering. Sintering is basically done in two methods. One, we call it the pizza oven. It looks exactly like the pizza oven at Pizza Hut. Goes down a conveyor belt that's about 25 feet long. Temperatures inside that oven reach 2,000 degrees Fahrenheit. Small parts will take about 4 hours to go down that. And what happens in that is basically that ferrite is fired, the binding agents are driven off, and it becomes like a high-strength ceramic material. Two different types. We have both we also have a box kiln that allows us to fire both in an oxygen atmosphere and a nitrogen atmosphere. The manganese zinc ferrites require a reducing atmosphere of nitrogen. So there's basically two types. A large piece of ferrite, like that block you saw in the previous thing, will take 4 days in that box kiln at 2,000 degrees to fully form. If you ever wondered why a piece of ferrite costs $5 or $6 and most electric components are about a penny, the truth is that almost all of it requires high energy or high heat. As you can imagine, those ovens are on 24 hours a day, 7 days a week. At 2,000 degrees Fahrenheit, the transformer outside the company that I worked for is about the size of all of these chairs put together. And finally, the last stage is finishing. Biggest operation here is the burnishing operation. We take each piece of ferrite, we tumble with plastic media to knock off all the sharp edges. We might gap it if it's a transformer core. We might coat it with paraline to insulate it if it's one of the manganese zinc beads. And we might also put a thermoset coating on it to do the same thing, basically to insulate it. So that's what I've got. Any questions? I'm not sure how long this is.
It was just a question on the binocular core. Yep. I see them using a lot of RF transformers, but are they ever used in doing common mode suppression and just running the two conductors through? Oh, sorry. Okay. With the binocular cores, are there ever cases where they just run two conductors through and just get the common mode suppression that way?
Yeah, we get that question quite often. Technically, that isn't the same. Basically, in common mode, the definition is, or the way you suppress common mode currents is both the supply and return must go through the same hole in the thing. In a binocular core, there's two holes. You're putting one, and then the return's coming through the other. It's not the same, technically the same definition. It won't provide the same. So we tell people not to do that, really. Anything else? Okay. No, I think we're good. Sure, absolutely.
Hey, that's a great presentation. Thank you very much. Yeah, good stuff. There is if you've got a box of ferrites, okay, the mystery ferrites, the guys go, $1, and you go out and you buy a bunch. Yeah. There is a procedure in the handbook in Chapter 5, I think last couple editions, for determining, using some measurements, which the ferrite is likely to be. Can't really guarantee it, but you can sort it out. It's kind of a pain in the neck. If you've got a big box, it's worth going through it. The best thing to do is when you buy this stuff, and we all do this, we put it in a box marked ferrite, get a Sharpie, silver ones work really good, or colored tape, and put it on there as soon as you buy it, because it looks like every other ferrite you're ever going to get. You'll never be able to tell them apart. You'll never remember which are the 31s and which are the 43s and all this kind of stuff. So identify them quickly. DX Engineering has started putting some paint on their cores. The powdered irons are painted, but the ferrites all look the same. So identify them right away. And the other thing is, if you look at them and say, well, I need 2 pieces, and you got to pay single lot prices. Get your club together and make a big order from Mauser or Allied or something like that, and then split them up amongst yourself. And when you take them out of the nice trays that you guys ship them in, make sure you don't just throw them in a bag, because they're brittle and they'll chip if you jerk them around and walk around with them. So some practical tips. Thank you very much.
Thank you. Okay, thank you, Bruce and Ward. Is the next speaker here? Are you the next speaker? I'm going to cut my next presentation down to about 2 minutes, and you come up and load yours. I sort of suspected there wouldn't be enough time to do this, so I'm just going to hit a couple highlights. Typically with RF, if it gets out, it gets in. It's a two-way street. But as Ward mentioned earlier, there's near field and far field. I've heard all kinds of arguments as where it changes from near field to far field. I consider it to be one wavelength. And for that reason, when the FCC, or you're doing tests to meet the FCC or any of the other regulatory agencies, you only start measuring emissions starting at 30 megahertz and going up. And from RF susceptibility, once again, you start at 30 megahertz and go up, because at 80 meters, the chambers would just be too damn big. And so the FCC says that a device must accept interference and it must accept interference caused by an authorized radio station. These are the FCC emission limits for a Class B digital device. This is in chart form. The thing I'd like to point out at 45 dB microvolts, that's basically a 20 dB over an S9 signal. So these limits aren't as great as what you think they might be. I got a link in this presentation to where you can see more about the FCC stuff. This is a typical current generation home computer plot. Because the current home computers in the gigahertz range, there's not really a whole lot there, except for below the 200 megahertz. And the reason for the stuff below the 200 megahertz is the switching power supplies. And your current generation motherboards, the one I just bought, has 27 switching power supplies on the motherboard. So you've got the switching power supply that's in the computer generating the power, but then you also have 27 more power supplies sitting on the motherboard. So all this noise below 200 megahertz is switching power supplies. This is what it looks like above a gigahertz. This is where this is a plot I found out on the web that shows the line conducted noise out of a switching power supply, and you can see.
Okay, anybody out in the hallway, I'm going to get started. If you're interested in the DX Marathon, come in. You all could move up here. It'll be easier to see the screen. It's your choice. Okay, good morning, everybody. I'm the last one on the program, but the best kept secret, as the program is, the DX Marathon program, but I want to make it not the best kept secret. I want to make it very visible among our community, particularly all of us that really enjoy working DX. So what I hope to do today is, from the 30,000 foot level, give you an idea of what this program is, how simple this program is. It does not compete or in any way preclude your operating contests or whatever you do. If you county hunt, whatever, it does not matter. You can do this program in parallel with zero incremental effort and have a ball doing it. And I hope to explain that to you today. Okay. Let me just give you a little background. I'll make it very, very brief. This year, I've been in this wonderful hobby for 63 years. I became a ham radio operator at 12 years old, so you can figure out how old I am. My dad and I built a CW crystal control 75-watt transmitter right out of the handbook. That was my first transmitter. I operated CW for probably 4 or 5 years. We found at a local ham fest in Peoria, Illinois, a RME 4300 receiver, and we strung a wire out back, and I was on the air. And since that time, for 63 years, I've been blessed with a lot of things in life. I'm a musician. I've flown airplanes for about 50 years. I rode my BMW motorcycle up here from Florida. I've got 4 BMW motorcycles. I've made 8 trips to the Alps in Europe. I've done a lot of things in my life. I've sailed sailboats. But I can say without question, a lot of those hobbies have come and gone. My ham radio hobby has never left me for 63 years. I've pretty much been active all the way from the time I first became a novice all the way through today. I retired 5 years ago. I graduated as an electrical engineer from Bradley University, followed by an MBA. I was an EVP for a large company that had responsibility for power generation equipment in the U.S. and Canada. And as I said, I retired 5 years ago, and I've really incrementally increased my focus and activity in this wonderful hobby that we all call ham radio. So what is the DX Marathon program? Before I get into some of the details, I can say without question, it's the fastest growing DX program in the world today. Why do I say that? Because year over year, between 21 and 22, we grew at 46%. And last year, 2023, we grew at 50%. Now, when I say grow, we had 46% and 50% more participants than we did the previous year. And similarly, the number of queues that those participants generated grew proportionately. There's no other program in a hobby that has relatively 2.75 million around the world and 750,000 in the U.S. that can claim that kind of growth. Now, why is it growing at that rate? Well, I'm not exactly sure. I did 70 Zoom meetings to clubs last year. We have tried to spread the word in all possible ways. I've done podcasts, and Cycle 25 doesn't hurt, okay? There's a lot of people on the air. My only explanation for why it's not growing faster is, for whatever reason, it's not visible, and that's why I'm here. I was at W4DXCC at Pigeon Ford. I was at W9DXCC up in Schaumburg, Illinois. I'm doing everything I can in my retirement to spread the good news, if you will, about the program. Because most people that sign up for the program just love it. Just love it to death. It's a lot of fun. And I hope to demonstrate that, at least give you a framework of that today. Okay, I'm a history buff. I'm going to give you a 3-minute history. Even though the program is not maybe so well known among our community, it has been around for a long time, in and out. Originally, it was introduced to our hobby by CQ Magazine's predecessor, which was called Radio Magazine, back in 1939. They introduced the program, and then along came World War II, and they shut it down. And they shut it down for 8 years until 1948, the year I was born. And they instituted it again, but concurrently, the DXCC, CQ Worldwide came out. There was just too much out there, so it just kind of died. So it stayed dormant until 2005, when this gentleman here, Bob Loker, some of you may not recognize his name, W9KNI. He was from Chicago. He now lives in the state of Washington. He approached CQ Magazine and said, hey, I'd like to reconstitute the DX Marathon program. And they said, Bob, have at it. So Bob spent some time, put the rules in place, went back to them, and they said, let's do it. So Bob is a very sharp guy. He also today is on my board of directors and a very active participant. He was no dummy. He knew that this was going to take a lot of time to administer, so he recruited young John Sweeney, K9EL, also in the Chicago, Schaumburg area, and John took over the program in 2005. That's when it came back into existence, and John literally administered the program for 17 consecutive years. And I knew John through a mutual friend of mine down in Jupiter, Florida, where I live. And we went to Visalia, we went to Dayton, and I got to know John. And lo and behold, about 2 years ago, I received through the Reflector that John was retiring. So I picked up the phone and called him. I said, John, what are you doing? He says, Mark, I'm burnt out. And I said, wow. I said, John, I just retired. Tell me about the program. I would like to give back something to this hobby for all the years that I've enjoyed it. So I spent about 10 minutes on the phone with him, and I said, oh my God, John, hold on. I can't do this. I just retired. I'm trying to build serenity into my life. This is a full-time job. So I got to thinking, we ended the phone call. I got to thinking about it, and in my professional experience, I built a number of companies, and I know you build companies and you do things through companies through people. So I said, John, what do you think of the idea of going out and recruiting some volunteers and dividing up all the workload that you did, all your tasks and responsibilities, among 4 or 5 people? And he said, yeah, I think that could be done. So I said, John, help me write job descriptions of those key tasks that you do, and then let's go out and recruit. Make a long story short, that's exactly what I did. And I said, I'm taking it over. So I've actually formed a board of directors. I formalized this program. We also today are an LLC, and I'm in the process of getting 501c3 qualifications so that people like yourself and many of our contributors can contribute to the program and achieve tax deductions. But I've got a chair, and we identified very experienced participants in the program, and they're my board of directors. And I'm no dummy either. I kept Bob Loker and John Sweeney on as board emeritus members, and I consult with them a lot. Okay, then what I did,
2/3 of our program is international. About a third is domestic, U.S. and Canada. So I knew that I had to have a sounding board as we evolved the program for international people. So I recruited pretty much from every continent participants, active participants, to use as my sounding board as we evolve the program. This is the heart and soul that runs the program. It's called my operating managers. I am very involved in it myself, but I've got a scoring manager. I've got an IT manager, Sebastian, who is at Dayton this week, who's absolutely an amazing gentleman. I've got a communications manager, and I got a rules and compliance manager. And I'm still looking for a data, and now I had a guy there, but he had some personal issues, and he had to walk off. But anyway, this is the operating group. We are now positioned to grow this program exponentially. What one man was doing, I now have 5 people doing, and we're very, very positioned to do that. Okay, what is the DX Marathon program? You're going to hear me say simple, simple, simple. I'll say that many times today. It is an annual program. It starts on January 1st and it ends on December 31st. And between those dates, you just go out and work as many DX entities as you possibly can. And I'll explain that in a minute. You log them, and at the end of the year, your log generates an ADIF file. You upload it to our web page, and then we score it for you. And then depending on what class you enter in, which I will explain also, or what mode you enter in, all modes or single mode or whatever, we then do a tabulation and we compare you against like operators throughout the world. This is not a contest, it's a program. Now, contests, as you know, I was a big contester. I'm very competitive. I kind of burn out, though. When I retired, I decided, again, I wanted serenity into my life. And serenity, I don't necessarily see as sitting at a station on a seat for 48 consecutive hours or 24 or 36. That doesn't build serenity into my life, and it doesn't give me much balance either. I got grandkids, and I got a wife of 49 years, so I try to get balance into my life. I still like to do that occasionally, but participation in this program, you can still do those contests, and everything you work in that contest will apply to this program. So my point was, this is a program. You can be competitive. We have a bunch of people that are competitive, but I once worked for a person that says, a brilliant guy, taught me a lot about business development. He says, Mark, if you can't measure something, it's not worth doing. All this program does for many, many of the participants is give you a self-evaluation on how you are doing in your DX pursuit. That's all it's doing. Before I took this position, I participated in the program for 7 years. I didn't need any plaques. I didn't need any certificates. I just wanted to know how I was doing. And I can tell you to this day, I participated in 2023. I have to pull myself out because I'm ahead of the program now. And my scoring manager, he can't participate either. But every single year I've been in the program, I have attained a higher score. That's self-evaluation, and that gives me an indication how much time I'm spending on the radio DXing, how I'm increasing my proficiency of chasing DX, how I have improved my equipment, my antenna systems, my station. It gives me a lot of feedback, and I enjoy that because I like to do as good as I can when I'm doing anything. I don't compete. I compete against myself. And I would say, I don't know the numbers, but I would say 3/4 of the people that participate in this program do that for that reason. That's all they care about. They don't care about beating somebody else. But if you do, you can do that, and it can be very competitive. It's an excellent excuse to get on the air. It's a little push, it's a little push. You can go on vacation for 3 weeks and not feel like you missed anything. You didn't miss a field day, you didn't miss a contest or whatever. You work it when you can. There's no sign-up fee, and there's no confirmations required. No QSL, no LOTW. It's an honesty program. We have some ways to keep the honest people honest, but I'll explain that in a minute. But basically, it's simple, simple, simple. Get on the air, work DX, log it, and turn in the file at the end of the year. That's it. That's it. Okay, let's move on. How does it work? I already said participation is easy. Okay, how is it scored? How is it scored? Everybody familiar with the DXCC entities? How many are there? 340. Those are all DXCC entities. To that, we add what we call the WAE entities, Work All Europe. There's 6 of those. So we have 346 distinct DXCC entities. And how many zones do we have in the world? 40. Each one of those that you work is worth 1 point. And all we do is take all your DXCC entities and all your zones, we add them together, and that's your score. No multipliers. You don't have to worry about multipliers, any of that complicated stuff that you get into contests. That's it. Okay? And it's very simple. We just add them up. Okay. Everything, a zone counts 1 point, a country entity. Now, so if you add those two up, what's the maximum possible score you can get? 386. Has anybody attained 386? Absolutely not. Because within those DXCC entities, there are what? Activations. Bouvet, Crozet, right? They're not activated every year. That's included in that 346. So typically, and I'll show you a little bit, scores, really, really, really good scores. If you get 300, you're doing real good. Last year, the top score was 329. That is amazing. Okay? So that's how it's scored. I got to keep moving along because I'll go long here. Okay, why participate? I don't know, out of those 2.75 million that are ham radio, you're going to pick that one to submit because you got a lock on it, okay? That's all your decision. We don't check for that. We don't check for confirmations. Okay. This is the submission form. This is hard to see. That little red box to the top left, that says load ADIF file. And that you take your ADIF file, you click on that, you point to where you downloaded it in your computer, up she goes, and you are finished. That's it, at the end of the year. The submission dates are between January 1st and January 5th. You've got to submit in that window because we have a lot of things that we then have to do afterwards. So it's a pretty tight window, but we seldom have problems. You can also, with the new submission tool that he developed, you can submit right now. In a month, you can submit again. Each subsequent submission will overwrite the previous one, so you will always have the current one on file. And they're not public because a lot of people say, well, why don't we make them public? Because we do have a lot of people that are very competitive and they don't want anybody else to know where they stand. So it's only available to you when you go in and check and when you log up. Okay? I'm going to just skip ahead here because I'm just going to say one thing about verification. Our program is an honesty program. We don't require confirmations. We encourage everybody that works somebody, put it in your log. Check it later, but put it in your log and even submit it. The worst that can happen, if you got a broken call or we get a non-confirmation, you don't get thrown out of the program, you get a 1 point deduct. So if you are at 301 and we find one that's not confirmed or you typed a 0 in for an O, you go to 300. That's it. Now, that doesn't sound much to you, but I can tell you in any one of these categories, the top 10 or 15 people are separated by less than 10 points. So to them, it's big. It's big. To most people, in 7 years, I've never submitted a perfect score. I've been dinged. It's getting better. Last year, I only had 2 mistakes. Okay, but it's not uncommon. Out of roughly 2,000 participants, we only had 300 that had perfect submissions where we didn't find an error. By the way, QRZ makes lots of mistakes. The zone designation, the CQ zone designation in QRZ is done by the operator. Some operators, believe it or not, don't know what zone they're in. So if your database tracks from QRZ and it's the wrong zone, you got the wrong zone. And if you submit it into your zone, into that claim zone, and it's wrong, you get a deduct. I went through my log about about a year ago, and I used DXKeeper, and it uses QRZ as the database for identification of prefixes and zones. I had a 1% error. I had, out of 35,000 queues, I had over 3,000 queues that had mistakes. How did I know it had mistakes? I used the AD1C country code database. Jim, out in Colorado, it's the best in the world, by the way. That's as told to me by K9EL, my predecessor. It's the best in the world. It found the mistakes. I went through my log and I corrected all 3,000 because I don't like a crappy log. I want it right. Okay, so beware of QRZ because it has about a 1% error. So double check that. Okay, the honor system, we have ways that we can go in. We don't do 100% checking of all your queues. We do spot checks. We do particularly close checks for people of the competitive type that are in the hunt, that are at the top, okay, because we've got to make sure we don't make a mistake on those. They get very upset if we make mistakes. So we scrub those a lot closer, but we do that. And the reason we do that, not because we have found people that intentionally cheat, but rare. Most of us in our hobby are very honest people. If we say we work somebody, we work somebody. So we want to protect those people that are honest. That's why we check. We know if we start having a proliferation of cheating or whatever, people will just say, they'll leave. They'll get frustrated. And we don't want to do that. That's the only reason we check. All right. DXpeditions, I get the ADIF files of many of the DXpeditions. I tell them who I am. I said, hey, would you mind sending me your logs? We dump them into our computer. If our participants say they work the station, we match. If they're not in the log, -1. Okay? So we do a little bit of that. That's what we do from the end of January through about the 1st of March, because we had 350, last year we had 350,000 queues. We didn't check all of them, but we checked a lot of them. Okay. We believe in recognition. We have plaques of recognition. They're beautiful plaques, and we have certificates of merit that we send for many. The major cost in our program is the cost of those plaques. They're about $100 a piece, and we have wonderful sponsors. We have individuals. We have clubs like the Northern Illinois DX Association. CW Ops, they sponsor 3 plaques. High CW in the world, High CW in US, High CW in Europe. Beautiful plaques, $100 a piece. That pays for the plaque. Without our sponsors, we wouldn't have a program. Okay, so we're very grateful to them. The certificates are just they're mailed like many other contests, so that really doesn't represent a big cost to us. We are indebted to our sponsors, though. Okay. Just a little commercial here. Down at the bottom of our webpage, it's hard to see here, but if any of our participants wish to make a donation to help offset, we're volunteers in the program, and if we can't get volunteer money, we pull money. John did it for years. He pulls it out of his own pocket. You know, printing cartridges and papers, and now that I'm growing the program, we have other costs. These things here, okay, those come out of our pockets unless our participants can throw $5 in or $10 in. I mean, 2,000 participants. We don't charge for the program, but if 2,000 participants, threw in $10, that's $2,000, and we could use that as working capital. Trust me. So if you're so inclined, it's a PayPal contribution. Very, very simple. That's all I'll say about that. There's a way to contribute if you wish. All right. All right. Who needs sunspots? Our program doesn't need sunspots. You know, sunspots are kind of, it levels the playing field. If it's good, our scores are high. If it's not so good, they're not so high, but it doesn't affect the number of participants that we have because everybody has the same penalty. But I'll tell you right now, it is very, very good. I don't need to tell you guys that. This chart is a little bit dated, but cycle 25 has just been absolutely amazing, especially on 10, 12, 15, 17 meter. It's 50% of the 350,000 Qs are on 10, 12, and 15. That's all cycle 25, basically. So I tell a lot of people, you know, if you're thinking about this program, get in it now. It's really good. It's really good. Okay, here's my bell-shaped curve. I referred to this earlier, so I won't spend much time. But, you know, I'm out in the 3 Sigma area on the edge. You know, people that have the kind of mega stations that a few of us have are not that frequent. Most people are inside the bell-shaped curve, and that's really who I'm going after on this program. People that are running 100 watts that have a wire or a vertical. You can get into this program and have an absolute ball. Okay, I'm going to say just a few words about 2023 result. This may be really hard to see. 50% growth in participation. The high score was 329. In 2022 is 307. This one is mind-boggling. We had 99 entries that had scores above 300. In 2022, we had 13. That's cycle 25. Is that amazing? The overall error rate, not bad. It's 2.0 this year. It was 2.7. People are getting better at checking their logs. What are errors? Wrong zones. I mentioned that already. Invalid calls. Pirates. Wrong country entities. Not in log. Only 6%. When we do log checking, we only find about 6%. One guy says, I worked the guy, and we check the guy on the other end. He says, he's not my log. So not many. 65% of our participants are in the unlimited class, you know, the big class. Only 5% single band. I'm really trying to figure out a way to increase that number. That means you select 60, you select 20, whatever. And about 36% were in single mode. They declared, I'm doing it only for CW, or only for digital, or only for sideband. And clubs, I'll talk about this in a second, but club participation, as I have wanted it, is escalating rapidly. And I want that because it engages a lot of people. It's healthy for our hobby to engage people. Continents, this is almost impossible to see. I'll read it. The line on the top is North America. The second line and the second largest continent participation is South America. Brazil in particular, they're huge supporters. I don't know if any of you went to the contest dinner last night. PP5JR, Sergio, I spent the weekend with him here. He was inducted into the CQ Contest Hall of Fame last night. He is a huge participant in this. Huge. And he has 3 children and a wife, and they're all ham radio operators. All of them are. Juliana, I introduced to Carol Perry. She gave a presentation to the youth teachers on Friday and to all the youth on Saturday. She's 14 years old, and she's an amazing young gal. She's very active ham radio operator. And then they go down from there. I won't boggle. And these are mainly statistics. QSO by bands, you can see. Single mode, I just mentioned. Clearly, the digital, like it or not, 76% of all the Qs that we accepted out of the 350,000 were FT8. About 14% were CW and about 14% for sideband. I'm working real hard to pump up CW because I personally like CW. And I'm now in the CW ops. I just got in that, even though I've been a CW operator forever. Somebody nominated me to be a sponsor for me. And there's 3,500 CW ops operators in the organization worldwide. So I was with Dick last night, who writes the CW op newsletter, which is, by the way, one of the best club newsletters I've ever seen in my life. It's phenomenal. But I've written an article on that. I'm trying to engage many of those CW operators into the program because I want to see that 14% grow to 25% within the next couple of years. Okay, these are just a lot of data here. This is I referred to 99 participants scoring over 300. That's that big bar at the right-hand side of the screen. Okay, I'm going to conclude. I did change. I'm very conservative. I'm from the Midwest. If something is running really good, don't screw around with it. But on the other hand, I want to constantly improve the program to make it attractive to more hams because my vision is to grow this program. I want to double it again next year. I want to double it the next year. The numbers are there to do it. I just learned my IT manager, anybody involved in POTA? You know how many people, POTA just started. You know how many people are actively involved in POTA right now? 11,000. It's incredible. It was nothing just a few years ago. Okay? With all the DXers out there, we're looking at peanuts in my program right now. So I'm really trying to find a way to attract people. I do that through outward reach, but I also do that by examining the program as it is right now, the merit systems, the reward, and tweaking it around to make it more attractive to engage people to participate. So I've tried to modify the categories. I talked a little about that to try to make them on an equal playing field so somebody doesn't feel, I'm disadvantaged in this category. So I want to feel like if somebody gets into it, they're playing on a level playing field. I am a huge proponent of youth. I spent half my time here in Dayton with youth. When I was in business, my business units, if I had a business unit that was doing this for a couple years, it made me very nervous because whether you're talking about a business, whether you're talking about a church, whether you're talking about a ham radio hobby, you do not stay at a plateau forever. There's two directions you're going to go. You're going to go this way or you're going to go this way. I want to see our hobby go this way, and the only way I can see that happening is feeding people in the front end of the hobby. Get youth involved. There are a lot of organizations that think like, and so I created a youth overlay 2 years ago, and I have a plaque, #1 youth in the world, 25 and under. This year, I'm issuing certificates for the #1 youth in every one of the continents, the 6 continents. So I'm doing whatever I can to increase. Youth love this program, okay? YLs, okay? Same thing. My wife is an electrical engineer. She's a ham radio operator. Both of my kids are, but they're not active. My wife is not real active as well, but that's okay. There are a lot of YLs out there. I was talking to the YL group. They're going to put me on the website. I have an overlay for YLs, okay? That doesn't mean YLs can't participate on an equal basis on any of the other It's just that I want to do a special recognition. So I've got a sponsor for the #1 YL in the world, and I'm issuing certificates for the top YL in each continent as well to try to engage the YLs. Okay, club competition. If you got a club of 25, I belong to a very small club in South Florida. How am I going to compete against a Potomac Valley club that's got 300 members? Because the way we score clubs is we take each individual participant, we just add them together. They refer to a club call, we aggregate it, and that's the club score. Well, how am I with 25 people? Again, I'm looking to try to create level playing field. So what I did for 2024 is I divided the club into 3 tranches, 75 and above, they'll have their own plaque and their own recognition. Between 25 and 75, they'll have one. And even the small clubs, 25 and below, they will have their own recognition, their own plaque. Okay? So I'm really big on club. So in honor at both at W4 DXCC, which I was at, and W9 DXCC, John Sweeney, K9EL, 17 years, I created an award in his honor. Okay, and the award is, I'm going to take the last 5 years of participants and I'm going to add their scores together, and the person that has the highest score will get the John Sweeney Super Marathon Award, just in recognition. Okay, and lastly, this one is, you're all familiar with the DXCC Challenge. This is similar. Okay, and one of our big sponsors in South America gave me this idea. So this year, 2024, for the very first time, we will allow entry into 8 bands. In other words, 10 through 80. We will aggregate your points in each one of those bands, sum them up, and see what you got. The top person will get a plaque in the world, and then the runner-up will get a runner-up plaque. This will be interesting. It's a brand new thing. This falls in the area where I want to make it more attractive. So I'm finished. I'll entertain any questions, and I hope to see you